Hi everyone, it's maths time again, and what are we looking at today? Well, we are looking at volume and capacity. And I hope that you've had lots of fun exploring capacity. Does anyone remember what capacity was all about? Yes, that's right. It is the space inside a hollow container. So if we have a container like this, we can put things inside. So we are looking at measuring the capacity, how to measure what can fit inside the 3D object. That's right. Now, if we had something like this, is that a 3D object? It is, because that's right, it's not flat. If you turn it on its side, it doesn't disappear. It's not an image. That's right. It is an object that we can touch, we can hold. So it is definitely a 3D object. But does it have space within inside it to fill? Well, it's got a little bit here, but that's not actually measuring the space that it takes up, is it? No. When we actually have a look at 3D solid objects and we start measuring those, which you might get a chance to do at the very end of this video if you want to do some further exploring, the measuring and exploring of this is exploring its volume. But we are actually today on the hunt for the perfect 3D object to measure our capacities. So I wonder, are there any special rules that we might need to think about? What were some of the special rules that we had for measuring a line and for measuring, which was 1D, one dimension, and we had two-dimensional measurements. That's right, it was our area measuring. What were some of the rules? Pause the video and see if you can remember, share with each other or with your teacher, what were some of the rules that we discovered from measuring? Oh, that's fantastic, everyone. It sounds like you do remember. So if you said that it had to have your objects touching end to end, just like when we measured a line with pencils, they had to actually touch end to end. Then you would have been right. We have to have them all touching. And what about when we had an area? That's right. If you said that they had to touch sides and that there were no gaps, you would be right too. We weren't allowed to have any gaps. And what about when you twisted and turned the shape? What happened to it? Was a rectangle okay? No, it wasn't okay, because when you changed it, the height changed and the width changed. So we discovered what shape was the best. That's right, it was a square. So a square was the best because no matter which way we turned it, it stayed the same shape. So I wonder if thinking about and considering those rules, whether we might be able to add those while we were exploring our 3D objects and the perfect measuring of those 3D objects. Well, I'm going to start. I've been exploring things in my kitchen. I've got some straws to start me thinking. All right, let's have a look at what I've found out so far. Well, I have a box that my daughter made me a while ago for Christmas. It's a lovely little box. And I've been discovering that some of the things, well, they do fit in really well. Like these straws in this container. They do fit pretty snugly. There are still, I don't know if you can notice, but in between there, oh dear, we have gaps. They don't actually fit together. Can you see in there? There are some gaps. Even if I push it very, very closely, there's like a triangular gap just there. So my straws, they didn't work. So I'm going to see if I can have a look at some other things too that might work. Maybe I'll choose my spirals. So if I hold my spirals into my container, they kind of fit pretty snugly end to end. They don't really fill it up either. I'll probably get some more, that's okay. But what do we notice? They are not the same dimensions. They are taller than they are wide, and they don't fit snugly with the shape. It doesn't kind of fit together. Alright, so that didn't work. What about our nuts? Here's some nuts. Getting there. Have to get some more nuts. What can you notice about these? Are these a good fit? They're not quite the right shape though, are they? But still, when they're circles, yes, they have these little gaps in between them, don't they? When they're spheres or spherical in shape. I think the same thing would happen if I was to do it with peas. Even they would be nice and round, but they'd still have gaps. Is that what you noticed? Maybe, if I show you what I mean, we can use some tennis balls. See if we can fit those in there. Oh, they kind of fit snugly that way. Or they don't really that way. But even if they... Oh, there we go. Fit that in there. Squish them in. Can anyone see what's happening? What's this? Nope. That doesn't work, does it? They are good spheres. And they do almost fill it to the top. But what's the problem? There are gaps. They are the same. Oh, they fit that rule. They're the same wide as they are high, and they are deep. See, if I turn it that way, they're the same deep. But the problem is they leave gaps. All right, pause the video. Maybe you've guessed already. What do you think is a perfect object that we might be able to place in there? So it's your challenge now to go and search for some shapes, some objects, 3D object shapes that are going to be the perfect for fitting inside boxes. That's the best place to start. Ones that are rectangular prisms or square prisms, so that you can see what is the best object to be able to measure. All right, so pause the video, you go do lots of exploring, and then I might say, show you what I've discovered. What do you think about this shape? What is this object? That's right, it's a cube. Now, does it fit the rule of the same, no matter which way you turn it? Yes, it is. The dimension measurements are the same. High, wide, and deep. So, let me have a go. I'm going to start packing them in. How's that looking, everyone? Do you think that might work? How's that going, everyone? What can you tell me? What do you notice? Well, what do you think of that, everyone? It almost filled it to the top. But what can you tell us about this unique object? Yes, that's right. It does fit end to end. It is the same dimension, width, height, and depth. And no matter which way I turn it, it stays the same. That's right. So, through our exploring, we have discovered that the cube is the best object. Now, I wonder though, if this was plastic, like this container, and we wanted to fill it, I wonder what would be the best substance, because sometimes we can't always fill things. As you can see, there's a little bit of a gap there with the rounded corners. Or if it was my drink bottle, no, that's not going to work. I wonder if you can also think of what might be best to go in here. So were you able to figure out that the best 3D object was a cube for measuring? And I wonder what else that you found out too that I haven't actually discussed here, but that you could write down. I hope that you did some really good discovering. So maybe I will start you off by writing some of the observations that we had. So this is my sentence that I wrote. The best 3D object for measuring volume. What was volume? That's right. Excellent. It is the measuring of the solid 3D object. And capacity, that's right, that's measuring the inside, if there's a space inside your 3D object. Its capacity is a cube. That's fantastic. Now you might do some other things in your workbooks or your papers. You might make a poster even all about your findings. You might draw pictures of what volume means. So you might draw pictures of things that are 3D solids. You might draw capacity, and you might put all the containers underneath that heading. You might also be very clever at drawing cubes by now after exploring 3D shapes. Now, if you've done all of those and you have discovered all those things already, you might like to get some Play-Doh or some clay and get one piece and then make some 3D objects. So looking at their volume. And what I'd like you to do, if you are up to that, make your 3D objects. You might take a video or you might take a picture of those. So I've done, what shape is this? That's right, it is a triangular pyramid. It's supposed to have corners. We'll just have to imagine that they're sharp corners, vertices. And then I want you to, when you've taken a picture of that one, compare it to another shape. So you might show how the same volume can become a different form, a different object. You might say, okay, that's the same volume, but this is how it looks. You might even squish it and say it's still the same volume, that's right, but the 3D object shape is different in its size this way and that way, so it can change. Well, I hope you have lots of fun exploring. There are lots of things to explore in volume and capacity. Remember to write down some of those things that you found out so that you can go back and have a look next time so that you can remember some of those rules. All right, well, have lots of fun, and until next time, enjoy exploring maths in the world around you.